section 7.2. We're going to be learning how to solve systems using substitution method. So this is the second method in this chapter. First one was solved by graphing. Second one, this one right here, is solved by substitution method, and then the third one will be elimination in section 7.3. So your goal for today is to solve systems using substitution. Well, remember, system is two or more equations together, and to solve means where the two lines intersect. So we're still looking for the point of intersection, solving for x coordinate and the y coordinate. So in a substitution method, we are to replace one of the variables of one equation with an equivalent expression from the other. And I'll show you how to do that in a minute. But you also use substitution when you have at least one equation is in slope-intercept form. So when you're given a choice of which method to use, you are to use substitution if you have at least one of the equations in slope-intercept form, which is y equals mx plus b. So in example number 1, I have this system right here, which is more than two or more equations. So this is the two equations of a line, and I'm going to solve this using substitution. So actually this right here, we could probably solve it by graphing, and you could even check if you want to graph it by graphing this and see where they intersect, and check your answer with this substitution method, and it should give you exactly the same answer. So in this substitution method, it says to replace one variable, and my variables are x and y, and we're going to use, we could replace one of the variables in one equation with an equivalent expression. This right here is an expression. So if you notice, this y right here is equal to this. So it's this y and this y are exactly the same. So in place of, so we're going to substitute this expression in for that y, because that's what that y equals. So we're going to substitute it in. So this right here then becomes, so when we substitute in, 2x plus 1 is equal to 3x minus 1. So if you notice, I replaced one of the variables with an equal expression from the other. So substitute it in. So now we're going to do is combine like terms, and we're going to solve for x. So I always like to bring the smaller x over to the other side. So this is positive 2x. You subtract 2x over. So then you get 0 plus 1 is 1 equals 3x minus 2x is 1x, or just x minus 1. And then to solve for x, I do the opposite. So I'm going to add 1 to both sides, so x is equal to 2. So my solution is 2, comma, and I gotta look for also the y value. So since this is my x, I could pick either one of these, and I'm just going to pick the top one, y equals 2x plus 1, and I am going to plug that in for x, and then we're going to solve for y. So y equals 2 times 2 plus 1, and y equals 2 times 2 is 4 plus 1, so y equals 5. So the point of intersection would be at 2, comma, 5. So to check, to see if these are, this point is where these two lines cross, what we're going to do is we're going to take both equations and we're going to plug those values in to see if the both statements are true. So this is my x and y, so we're going to plug it in. 5 equals 2 times 2 plus 1. 5 equals, this is 4 plus 1. 5 does equal 5, so this side checks. Now let's plug in for this. 5 equals 3 times 2 minus 1. 5 equals, we're looking for if these are equal, right? So 6 minus 1 does 5 equals 6 minus 1, which is 5. So that one also checks. So this is a substitution method where you take one of the variables and replace it with the equivalent expression from the other. So I'm going to give you another example, number 2. In example number 2, I am given a system of equations. So we're going to solve using substitution. Now later on when we are doing this, and if it doesn't say by which method, you could choose any method to solve. But with one of them, if at least one of them is in slope-intercept form, I would use substitution. But in this case, it says solve by using substitution. My system is given by negative 2x plus y equals negative 1, and the other equation is 4x plus 2y equals 12. So there's my equation. So there's my system. Now to use substitution, at least one equation has to be in slope-intercept form. I'm going to choose this one to rewrite. So rewrite in slope-intercept form. And I choose this one because all I have to do is to get y by itself, I would add 2x to both sides. So y equals 2x minus 1. This is positive, so 2x, and then that's minus 1. So now I have one equation in slope-intercept form. And what I'm going to do is I'm going to replace one of the variables, which is y, with an equal expression from the other. So since y equals 2x minus 1, in place of the y over here, I'm going to substitute it in. And so that's called substitution. So 4x plus 2 times, now, I'm going to put that in parentheses, so 2x minus 1. And I'm substituting it for that y is equal to 12. So this is my y right here. So then I'm going to do is I'm going to distribute 4x plus 2 times 2x is 4x, and then 2 times minus 1 is minus 2 equals 12. I'm going to solve for x. And since these two are on the same side, I'm just going to do exactly what it says. 4x plus 4x is 8x minus 2 equals 12. And then we're going to solve for x. So I'm going to add 2 to both sides. So then 8x is equal to 14. And I'm going to divide by 8. X is equal to, I'm going to reduce 7 over 4. So there's my x. 7 over 4, or you could say it is 1.75. Now I got to look for my y value. So here's my, so what I'm going to do is you always go back to the original. This and this. So I'm going to just pick this one because it's easier. Negative 2x plus y equals negative 1. And what I'm going to do is I'm going to take that x and plug it in there. So negative 2 times 7 over 4 plus y equals negative 1. And because this is a fraction, I'm going to rewrite that as a fraction. And if you noticed, 2 goes into 2 twice, 2 goes into 4. 2 goes into 2 once, 2 goes into 4 twice, and then this reduces to negative 7 over 2 plus y equals negative 1. And then to solve for y, I'm going to add 7 over 2, add 7 over 2. So y equals, now I need a common denominator, so this becomes negative 2 over 2. So negative 2 over 2 plus 7 over 2, so negative 2 plus 7 makes it negative 5 over 2. So this is my y value, which then, so the point of intersection with the solution is, positive 5 over 2, because negative 2 over 2 plus 5 over 2 is positive 5 over 2, or I could say it is 2.5. So this is the point where these two lines intersect. And you could check also. In the last example, example number 3, it's a word problem. I have youth group with 26 members are going on a trip to a beach, and along with the 26 members, youth members, 5 chaperones will be joining them, and each of them will drive either a van or a car. So if you notice, they're going to be taking 5 vehicles, either a van or a car. Okay? And each van seats 7 people, and each car seats 5 people. My question is, how many vans and cars are needed? That's the question we're answering here. So like any other word problem, you always go to the question part of the problem to define your variable. So when I define, because I'm looking for the number of vans and number of cars to drive, I'm going to let x be the number of vans, and I'm going to let y be the number of cars. And if you notice, because we have 5 chaperones and each of them are driving either a van or our car, you know that there's a total of 5 vehicles. So x number of vans plus y number of cars should equal, so x plus y should equal 5 total vehicles. Now we also know that there's a total of 31 people going on this trip, because there's 26 youth members plus 5 chaperones. Together makes it 31. And here's the other part. Each van, 7 people, so that would make it 7x. So that would tell me how many people are in the van. Plus, each car holds 5 people, so 5y together should total 31 people. So this is my system of equations. And we're going to use substitution to solve for this. So what we're going to do is we're going to take this equation and rewrite. So we're going to x plus y equals 5. So we're going to solve for y, so minus x. And remember, you don't always have to solve for y. Sometimes you can even solve for x and substitute the equal expression for x as well. So I get negative x plus 5. And we're going to take this in place of this y, because that's what the y is, and we're going to substitute it in. So what I get is 7x plus 5 times y being negative x plus 5 equals 31. There's my substitution. And then we're going to distribute. So I got 7x. 5 times negative x is negative 5x, or minus 5x, and 5 times 5 is 25, equals 31. And this is on the same side, so 7x minus 5x is 2x plus 25, which is equal to 31. And then we're going to solve for x, so minus 25, minus 25. So what I get is 2x equals 6, and then I'm going to divide by 2, and divide by 2. So x has to equal 3, and x is the number of vans. So we got 3 vans, and because there's a total of 5 vehicles, I have 2 cars. And that's my solution. And this is a substitution method for solving the system of equations.